In this video, we'll see how bitwise operators can be used in C++ programming language. Let us see what are the operators and what are their symbols. But one thing one should know and always remember that bitwise operators are applicable to only integers. There are four bitwise operators. One is bitwise OR. This is its symbol, vertical bar. And this is for bitwise AND, ampersand operator. And this one is bitwise NOT. We call it a tilde operator, TILDE. And this is referred to as bitwise exclusive OR. So this is bitwise exclusive OR operator. Let us see the truth tables for each one of them. You may be knowing, just for a recapitulation. Here is the truth table for bitwise OR operator. So you can observe here, if both the inputs are, or sorry, if any of the inputs is 1, output would be 1. So here it is 1, output is 1. Here this is 1, output is 1. Here both are 1, so output is 1. It can be seen in this small example. X is 30,000, Y is 31,237. So their bitwise OR operation would result 32,565. One thing to be noted, here it is for calculation and example purpose only. So I have assumed that we have 16-bit machine as it used to be in case of Turbo C++ 3.0, etc., where the size of an int was 16 bits, etc. So here you can see 0, 1, result would be 1, and continue till this. But remember, when we actually convert this into a program, C++ program, output would be different. Different in the sense it would have, in this case, result would be same, but the bit pattern printed would be bigger if you want to print the bit pattern, because the size of an int is 32 bits. So this is just for explanation purposes. Now next one is bitwise AND. So here, if any of the inputs is 0, output would be 0. Likewise, same example, you can see here 0, 1, result would be 0. Here 0, 0, same 0, and so on. So output is supposed to be 28,672. Next comes bitwise NOT. So if input is 0, output would be 1, and input is 1, output would be 0. Now this has to be looked at very carefully. Here, for sake of explanation, I have written the result mathematically, that it's a 1's complement, that is the NOT, bitwise NOT, would should give 35,535. But actually, in programming languages like C, C++, etc., if the size of int is, or integer is 16 bits, then MSB is most significant bit here used is to represent the sign, and if it is 1, then the result is negative. That is, number is treated to be negative, and all negative numbers are treated or stored as 2's complement. They are stored in 2's complement format. So 2's complement is, flip the bit. If it is 0, it becomes 1, 1, it becomes 0. And if the number happens to be negative, take 2's complement means first take 1's complement and add 1. So we will see in the working example. Here, bitwise exclusive OR. So if both the inputs are dissimilar, then only output would be 1. Otherwise, output would be 0. It can be verified from here. Both are different, so output is 1. Here both are same, output is 0. And let me find any other one. No, there is no other place. Here it is 0, 1, 1. So whenever both the inputs are like here, these two ones, result would be 0. Similarly, these two ones, result would be 0. Okay, so let us see a working example. I have made a C++ program. Let me execute it on the left pane. Now it is asking me to type in two integers. If you see, I have declared two integer variables. As I told you, bitwise operators are applicable to only integers. So here, two integers are expected. We would supply two integers. For example, 5 is 10. So now this C out, it is supposed to print the value of bitwise OR. Okay, so this is bitwise OR here. Similar lines, on the similar lines, this prints bitwise AND. This prints bitwise exclusive OR, and this is interesting. This prints bitwise not of 5. Now you can see here x equal to 5 because this is unary operator. Okay, so tilde x, that is bitwise not of x, is minus 6. How is it? As I told you, actually, when we flip the bits of any integer, and if the most significant bit becomes 1, the number is treated as negative and it will be represented as in 2's complement format. So I have made another program, bit count. Type an integer. Suppose if I type 5, now you can see here its binary pattern is here. Number of ones is 2. You can see here. And since in C++ size of an int is 4 bytes, so 0 through 31 bits, that is 32 bits, most significant bit, if it is 0, the number is positive. If it is 1, number would be treated as negative. So here is 5. Okay, now let me rerun this and type minus 6. Now you can see minus 6 has 30 number of ones. Now you can see, okay. Now if 5 is to be converted, now you can check here, if 5, I want to find out the bitwise not of 5, then what would happen? This is the bit pattern for 5. Okay, flip each bit. So these bits become 1 and this 1 becomes 0. This 0 becomes 1 and this 1 becomes 0. Now add 1. So this would be 0, 1, 1. Okay, 0, 1, 1. Okay. Now you can check here. It has to be minus 1. If you add, result would be this. So this is the bit representation of minus 6. You can verify. You flip all these bits. These bits become 1 and then this becomes 0. This becomes 1. This becomes 0 and you add 1. Okay. So if I rerun this program, bitwise operator, and if I type two integers now, 5 minus 6, then you can see here 5 bitwise not is minus 6. Now if I rerun and instead of typing this, I will say okay, minus 5, okay, and 6 suppose. So for minus 5, bitwise not results in 4 because most of the bits are already, they are already 1. Okay, in case of minus 5. Okay, so bits are 1. So you flip them and add 1. So what's the result? Result is, if there is a negative number, take its 2's complement. What is the value expected? Negative number. Find out the absolute value, increase 1 and put minus sign. So 5 becomes minus 6 bitwise not. And on the contrary, if number is negative, then take the absolute value, decrement it by 1 and apply the reverse the sign. So minus 5, its bitwise not would be 4 and 5 and its bitwise not would become minus 6. Okay, so that is all in this video. Thanks for watching.